This video will explore some of the common pedagogical approaches that can be used in numeracy and mathematics. Within the video, we will look at some of the common approaches that can be used in numeracy and mathematics, provide links to resources, and signpost further professional reading for those who would like to explore things in a bit more detail. Before we look specifically at mathematics, it is worth briefly looking at what the term pedagogy actually means. A common definition is that it is the methods and practices of a teacher. This is the definition in the Oxford Dictionary and is also a common definition on various other online searches. There is a quote in a paper written by Rob Coe in 2014 which states that pedagogy is more than just a set of techniques, but about knowing which approach to use and when to use it. These definitions are by no means explaining pedagogy in full detail, and we could spend hours and hours discussing the meaning of pedagogy, but for this video, we will use these definitions to lay the foundations of what we explore. Before we move on to specifically looking at numeracy and maths, it is worth looking at some of the common pedagogical approaches that are often used in learning and teaching more generally. The purple boxes show different pedagogical approaches to learning and teaching, and each one is slightly different. Teachers often choose which method is suitable for their learners. This might be a combination of these approaches. The green boxes show some of the approaches that might be part of these wider pedagogical approaches. Many of these you will recognise already and will likely already be using some of these approaches as well. We're not going to go into any of these in more detail, as the rest of the session will focus on the different approaches that we can use when specifically teaching maths. It is just worth highlighting this as it helps to set the context for this video. Looking now specifically at numeracy and mathematics, on the screen you will see examples of some of the high-profile approaches that are often used in learning and teaching. These are the approaches that this video will focus on, but there are of course other approaches that could support your learners. First of all, let us look at concrete pictorial abstract, as this is probably one of the most highest profile of the approaches and has received a lot of attention over the past few years, with more and more people beginning to introduce it to their practice. We won't spend too long on this approach with it being so high profile, but it is important that the approach is included within this video. Concrete is the doing stage, using real, actual objects to solve mathematical problems. In these examples, buttons have been used, but it can be anything. Counters, small toys, wrecking wrecks, and many more, and we will look at some more examples in the next slide. Pictorial is the seeing stage, where learners use different representations of objects or ideas using pictures or drawings or diagrams. And abstract is the more symbolic stage, where learners are able to use abstract symbols and to model and solve mathematical problems. This slide shows some of the common concrete materials that can be used. There are lots of manipulatives that can be used in maths. You may have used some of these before, and it's very likely that your establishment has at least some of these resources already. It is also possible that some of them are lying in a cupboard and not being used. Some of you might be more comfortable using certain manipulatives. We're not suggesting that you go away and start using all of these, but consider which ones best support your own learners, as each situation and context is very different. But also, don't be afraid to try something new too. We would like to draw particular attention to the natural resources and everyday items that you can see. Sometimes these can be overlooked, and with more and more teachers now looking at how to take learning outdoors, the natural materials can be used in so many different ways. The list is of course not exhaustive, and there are more that we've not included on here that you will likely come across. We often get asked for examples of the pictorial stage, as sometimes this is the stage that people are less familiar with. The pictorial stage might come in the form of any of these on the screen, and again, they're not the only pictorial representations, but they are just some of the more commonly used ones. Empty number lines can be really effective in representing thinking pictorially, and we have recently created a mini guide on number lines that we're looking to publish shortly. We haven't created an abstract slide, as This is the more formal algorithms that you will use with your learners. The reason we're highlighting this approach is because we want to emphasise the importance of the concrete and pictorial stages before moving on to the abstract. Although CPA is often shown as 3 distinct stages running C, then P, then A skilled teacher will go back and forth between each of the stages to reinforce the concepts. You might find that CPA is used quite commonly in lower stages of your establishment, but might be less known and used in the upper stages. We sometimes find that learners who have gaps in their knowledge or who have developed misunderstandings might have been moved too quickly onto the abstract concept without enough time to explore the concept at the concrete and pictorial stages. And you might find that you have to take learners back to the concrete and pictorial stages to ensure that they have a firm understanding of what the concept actually means. We know that not everyone has access to a wide range of manipulatives, but there are a number of online manipulatives that you can access to, whether it would be to demonstrate examples or for individuals to use on individual tablets or computers. It is useful to access these online resources. MathSpot and Toy Theatre are both free resources, and there are other websites available, but these are just a couple of the popular sites that we know that people find useful. We mentioned a few different pedagogical approaches in numeracy and mathematics earlier, and we've been pulling together some easy to access guides for these. We also have a numeracy and maths professional learning community. It is our one-stop shop for all the things that we offer, and we update it regularly. You can access this by using the hyperlink in the slide or by scanning the QR code. You will need to log into Glow to access this site. On this site, there is a link to key policy documents and guidance, professional learning opportunities, support for outdoor learning, and much, much more. We also have a news feed, which we update regularly, and it is worth checking in this at least once a week if you can, as we put up some really useful links up there on a regular basis. Within the professional learning community, you will find a selection of pedagogical mini-guides in relation to the numeracy and mathematics. This can be found by clicking on the Learning, Teaching and Assessment tile. We know how busy life is for practitioners, so we started to create these pages of mini guides that can be dipped in and out of quite easily. They are short and they're to the point. Each guide is only a few pages long. They explain what the process is, how it works, provide a few examples and links to further reading if you would like to investigate them something a bit further. We're in the process of creating a few more of these, and there is also an option to make suggestions on this page of other guides that you think might be useful. We don't have time to look at all of these today, but on the next slide there is an example of what one of them looks like. These are screenshots of one of the guides we have created on bar models. You can see that it gives a very brief description of what it is, examples of what it might look like at different levels, and how this approach could be useful, and then further reading links should you want to find out more. So what are bar models? Well, bar models are pictorial representations of known and unknown quantities, and they build on an understanding of the part-whole model. They can be used to help visualise the mathematical structures within problems and to help learners identify a successful strategy to solve them. Bar models have been popularised by the Singapore maths teaching method and play an important role in a concrete pictorial abstract approach. Bar models can be hand-drawn, but digital versions are also available on some of the platforms such as MathSpot. Again, if you would like to explore these further, you're welcome to read through the mini-guide. Another approach that can be used in maths is numberless word problems. Do you find that sometimes learners go straight to the numbers without really considering what the question is actually asking them? Numberless word problems is an approach that can stop the learners from trying to answer a question too quickly and without really thinking about what it's asking them. It essentially forces them, and us, to slow down and really take time to pick apart the problem and have a good discussion about the maths that is involved. In this approach, a worded problem is provided. However, the numbers have been removed initially and then gradually introduced a step at a time. So let's look at how this works. Have a look at this bubble on the screen here. What maths do you see? Take a moment to consider this. Learners might say none, as there are no numbers. but some learners also might start to link the words some and fewer as being maths related. So let's look at the second bubble. What new information do we have? And how does it help us? Take another moment to consider this. Finally, the full details are revealed, and however, you will notice that there's still not an actual question being asked here. You could set them a question at this point, or even better, you could ask the learners to create potential questions using the information that they have. Is this something you would want to use for every word problem? Probably not, but it can be a very good way of prompting rich discussion and can provide a scaffold to support learners in attending to information and language within worded problems. If you choose to use this approach, these are some of the questions that might support you in using this. Of course, you would not use all of these questions at once, but they are just there as a starter for 10 for you. The link at the bottom of the slide will take you to a link that has lots more problems for all different levels. The next approach that we're going to look at is called slow reveal graphs. These can also be known as notice and wonder graphs or numberless graphs. Graphs are gradually introduced one step at a time with a little more information added at each stage. Time to discuss, think and wonder is important at each stage for the learners. And as more and more of the graph is revealed, learners refine their interpretation, and sometimes this can be in surprising ways too. Take a moment to look at the graph on the screen. What do you notice? And what do you wonder? Next, a little bit more information is provided. What new information do we have? Does this change your thinking? And what do you wonder now? Again, some new information is revealed. What do we know now? What might be on the x-axis? Give learners lots of time to process each stage and really think about what it is that they are seeing. Finally, the rest of the graph is revealed. How did your thinking change over time as you went through that process? A lot of research has been carried out into cognitive overload, and this method is a great way of drawing attention to the finer details of graphs. Any type of graph can be used, and the amount you reveal each time can depend on what you feel is right for your situation. This approach could be used at different levels with data that is appropriate to the level the learners are working at. The last link gives a link to a graph about food waste, and it can link nicely to other areas of the curriculum. All of the graphs that are on that slowrevealgraphs.com are American, so please do use them with caution. You can make up your own quite quickly using the graph tool on Excel. Moving on to the next approach, goal-free problems. Goal-free problems are about exploring what different problems can be solved using a given set of information. It is suggested in the Sweller paper that we link to here that solving traditional problems which have a specific goal or solution can be cognitively demanding, particularly when the problem is in an unfamiliar context. This is because the solution can only be found by completing all the steps that lead to it. This cognitive overload may result in failure to solve the problem. And even if the problem is solved, it might not always lead to new learning. When a context is presented with no specific goal, the information can be explored at a level that is appropriate to each learner, and the solutions to many problems can be found. Learners can feel more in charge of what they are doing and feel less like they are working their way through a page of preset questions. And the beauty of this is that learners can bring in their knowledge and skills from other areas of numeracy and maths, such as number, fractions, ratio, percentages, etc. It doesn't have to be only used within data and analysis. This approach could be used more widely. And on the screen here, you can see some more examples covering different areas ranging from early level through to higher maths. Once you've given learners a chance to work out what they can, at that point, if you wish, you can share this goal-specific question with them. They should then realise that the hard work of answering the question has actually already been done, and a final tweak might be all that's now needed. We have also produced a mini guide on goal-free problems, which we've linked to here, and if you're interested in finding out a wee bit more about it, you can go on and have a look. Same surface, different depth problems were introduced by Craig Barton based on a paper by Roher, Dedrick and Burgess. When learners solve lots of problems using the same strategy, so for example a page of subtraction followed by a subtraction word problem at the end of the page, they don't actually have to select a strategy. So when learners tackle problems on a mixture of topics, they often dive in with both feet instead of carefully reading the information and forming an appropriate strategy. The same surface, different depth strategy seeks to address this. With these type of problems, the learner is presented with a number of problems which at first glance look quite similar, but actually each of them requires a different strategy to solve it, and so the learner is discouraged from making assumptions about what they're being asked to do. And again, we do have a mini guide available should you want to explore this further. These examples on the screen come from a website created and curated by Craig Barton, which is the first link here. The site has over 200 sets of free to download problems shared by teachers across the world. We're now going to look at retrieval practice. Retrieval practice is the recall from memory, knowledge and skills which have been encountered previously. It is the way that access to that learning can be maintained. Essentially, it is one way of helping the learning to stick. You could say it's a case of use it or lose it. To be effective, learners should aim to recall their learning without using notes or other aids, and it's this struggle that helps make that learning more permanent. There are a wide range of techniques that can be used to retrieve learning, and these are not just for maths. Learners could create mind maps, carry out number talks, accessing previous calculation strategies, or they could use low-stakes quizzes, which are a collection of questions on a variety of topics learned over time. Another method that can be useful is the three-pile flashcard method. This is where learning is added to different flashcards. Learners run through each flashcard, and as they do, they sort them into piles. An I know pile, I kind of know pile, and I don't know pile. This approach is probably most helpful for older learners who are studying for exams. And another method which we have seen successful is the last lesson, last week, last month, last term approach. This is where you pose questions regularly or provide tasks which access learning which has previously taken place. Again, we have a mini guide which focuses on retrieval practice, and there is also a professional learning model called Using Retrieval Practice as a tool to improve pupils' learning in mathematics. That can be found on the Professional Learning and Leadership site. The final thing that we're going to look at is our effective questioning guide. We have recently published this resource which looks at some of the different questioning approaches that can be embedded into learning and teaching to support your daily ongoing assessment of where learners are in their learning. It explores different types of questioning approaches that can be used within maths, explains what they are, provides examples and highlights what assessment opportunities they provide. It also includes some collaborative tasks that could be used within staff or department meetings. But the key message from this guide is that questions should be a part of assessment approaches and embedded within lessons. They should also be incorporated into your planning. This video has been a bit of a whistle-stop tour to highlight some of the resources that can enhance learning and teaching approaches in maths. This slide provides links to further professional reading sources should you want to explore anything further. Thank you for taking the time to watch this video. If you have any questions or comments, you're welcome to email the Numeracy and Mathematics team at mathematics@educationscotland.gov.scot. Thank you again for listening.